Yes. Hi, hello, namaskara champions. So this is your Premila Ma'am. Hegadira Ellaru. I hope you are all doing good. And today we are going to deal with one Dhammaka chapter, which is electrochemistry. So yes, my dear. I hope my audio video is all clear, perfect, and picture clear. So quickly let me know, Dakana. Quickly let me know. Bega, answer Madi. Let me know if I am audible. If Let me know if I am clear, so that we will quickly, straight away start the session. I hope things are going fine, superb, and pakka there. Yes. Okay, so who are all there? Who are all ready to crack your third exam? PUC third exam. So let me know in the comment section, Dakana. Aishu, Vedant, Pallavi, Uday Gaming. Hi, Dakana. Let me know who are all there in the comment section, because trust me, the sessions which we are about to bring now, be it any one shot, be it physics or chemistry or be it biology sessions, it is going to be super duper important for you. You guys are going to get extremely good resources and notes from this session. Not just this, but the entire series of session. So yes, I want you guys to be there throughout the live. Make sure that you cover physics, chemistry, and biology without fail. Yes. Okay, so shall we start? Wonderful, Rakana. So talking about electrochemistry, this is that kind of a chapter wherein which you can get beautiful, wonderful, systematic questions. And yes, in today's session, we are specifically going to talk about electrochemical cell, like what basically electrochemically means to, what are all the systematic changes which happens in electrochemical cell, so on and so forth. So quickly, can we go into the basics, my dear? What do you mean by the term electrochemistry? Could you please tell me what do you mean by the term electrochemistry? Yes, Akana. I want you guys to answer. Muttu, sure, Dakana, for sure. I'll come up with a smart board soon. As of now, since I am, using green screen, I have been continuing this, but don't you worry, I'll come up with smart board soon. Okay, within maybe this month or next month, I'll come up with smart board. Okay. So yes, Dakana, quickly let me know. What do you mean by electrochemistry? On looking into this term, what do what kind of a thing come into your mind? What do you mean by electrochemistry? Bega, answer Madi. This is going to be super interactive session, so I want you guys to interact and let me know what is it exactly. So have you heard of the term electrons? Right? Have you heard of the term electron? When an electron flow from one point to another point, what do you call it as? When an electron flow from one point to another point, what do you call it as? Yes. You call it as correct, right? Or you can call it as electrical energy. Fine. So electrochemistry is a branch wherein which we talk about electrical energy and chemical energy. Just split the name into two, my dear. You are going to talk about electrical energy and chemical energy. If I want to specify it more, then electrochemistry is the conversion between electrical energy and chemical energy. If you convert an electrical energy into chemical energy, or if you convert a chemical energy into an electrical energy, it is called as electrochemistry. The study is called as electrochemistry. But one quick question, my dear. If you want to convert one source of energy into another source of energy, then what do you need, Dakana? What do you need? What do you exactly need? Yes, I can hear your answers. You need a device to do that application, right? Yes, if you want to call me, you need a mobile phone. If you want to type a mail, you either need a mobile phone or a laptop or some kind of a devices, right? Similarly, if you have to convert your electrical energy into chemical energy, you need a device. Here we use a device which is called as electrochemical cell. Hi. Ella. Hey, Ella Linga. Welcome on board, Rakana. Welcome. So, yes, in order to convert your electrical energy into chemical energy and your chemical energy into electrical energy, you need a device which is called as electrochemical cell, ECC. Now, the question is, what is this electrochemical cell's function? And what are all the types of this electrochemical cell? Can anyone tell me? Linga, can you tell me? Muttu, can you tell me? Or Aishu, can you tell me? What are all the types of electrochemical cell? Hi Rakesh, welcome on board Kanna. Yes, can you please tell me what exactly it means to? Yes. Hi Vedant, welcome. So yes, could you please tell me what exactly happens in an electrochemical cell, or what are all the types of an electrochemical cell? Bega answer madi kanna. Any idea? Yes. Oh my dear smarty pants, open up your mouth the kanna. Please, let me know your answers. Yes. So an electrical cell is of two types. Yes, I know you know the answer. One is galvanic cell and the other one is electrolytic cell. One is galvanic cell and the other one is electrolytic cell. So quickly, can you tell me what happens in a galvanic cell? What happens in a galvanic cell? Yes. Any one of you. What happens in a galvanic cell? Yo, what Rakana? Do you really don't know what happens? I want you guys. I thought you guys are extremely smart. So quickly answer me. If you really like RCB, you are going to answer me. Okay, if you really like RCB, you are going to answer me. Yes, Vedant? Quick. Okay, Priya, chemical energy to electrical energy, huh? Very good. I can see whenever I say the term RCB, I can get the answer, Dakana. So yes, my dear RCB fans, it is absolutely true. Whenever you convert a chemical energy into electrical energy, the cell which you use for this conversion is called as a galvanic cell. Yes, similarly, whenever you convert an electrical energy to a chemical energy, the cell which you use for it is called as an electrolytic cell. So quickly tell me, guys, you're from various parts of Karnataka, right? So Vedant, Priya, Rakesh, Linga, Keetana, Muttu, Aishu, quickly tell me from which part of Karnataka you are. Yes. I had been to Bangalore, I had been to Mangalore, I had been to Mysore, Coorg. So quickly tell me which part you are from. Yes. Ray, open up your mouth, da kana. Come on, let's speak. Okay, Vedant, where are you from? Rakesh, where are you from? Linga, where are you from? Quick. Answer me. Okay, Priya is from Bangalore. Rakesh is from Mysore. Very good. Linga is for Gulbarga. Wonderful. Asha, where are you from, Dakana? Hi. Muttu is from Dharwad. Okay, wonderful. I have actually been to few places, Dakana. I had been to, Bangalore, Mysore and I love the climate there, especially the climate, right? It is so, it's not so warm and not so cold, but perfect climate which you have there, right? Yes, Asha, where are you from? Others, quickly let me know. Yes, where are you guys from? Okay, Sirsi. Very good, very good. I have heard about the place, Dakana. Very good, very good, very good. Others. Wonderful. Ajay Ram is also from Sirsi. Wow, wonderful, wonderful, wonderful. Super, 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 Dakana. Asha is from Sirsi. Superb. Pakka, pakka, Dakana. Very good. So, talking about me, basically, I'm from Kerala, Calicut. Had been to, right now I'm in Tamil Nadu, but still I had been to multiple places. Like I had, I have worked in Bangalore, I have worked in Hyderabad, I have worked in Delhi, many, 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 many places. I can, list out lots of places. So, yes, I really love Karnataka. So, coming back to the topic, Dakana, when you talk about an electrochemical cell, you know that an electrochemical cell is of two types. Just like how you guys, most of you are from Mysore, are from Bangalore, are from Sirsi, are from Dharwad. I can see lot of people coming from lot of locations, right? Similarly, a galvanic cell is the one, or it is the place wherein which a chemical energy is converted into electrical energy. Similarly, an electrolytic cell is the place where electrical, or it is the device where electrical energy is converted into chemical energy. So, how can I remember this, ma'am? Ma'am, this is a bit confusing. How can I remember this? So, I'll give you one short trick to remember this. Array, don't tell it to anyone, okay? So, the trick is G for galvanic and C for chemical energy. E for electrolytic and E for electrical energy. So you just have to understand which energy is converted to which. Okay, if you understand the first energy now, you can see chemical energy. C is somewhat similar to that of the letter G. That is why I say chemical energy to electrical energy stands for galvanic cell. Similarly, if in case of electrolytic cell, I would say that in electrolytic cell, it converts what? It converts electrical energy to chemical energy. Here you have the term E, here you have the term E. So just relate the terms, relate the words and understand what happens in which cell. Okay, is that clear? So my dear champions, do you have any doubts so far? If you have any, please let me know. Please let me know quickly in the comment section, Dakana. Asha, Ajay, Namika, Muttu, Linga, Rakesh, Vedant, any doubts? Any doubts? Yes. Also, Vedant, I cannot see our Aishu and other people out here. So if you know them in person, please let them know that the session is ongoing and ask them to come and connect in the session. Okay. So yes, 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 guys. Next, we will talk about what exactly happens in a galvanic cell and what exactly happens in an electrolytic cell. Okay, very good, very good, very good, Rakesh. In COMEDK, you have got 90 out of 180, right? So, for RV college, I'm not sure, Dakana, but there are chances, okay? So, please check, please check, please check. Are you looking for RV College of Engineering or for architecture, Dakana? Yes? Yes, yes, yes. Because if you take COMEDK cutoff now, for computer science it is going to be super high. For computer science it is going to be super high. But for maybe any other courses, you can for sure check RV college is available. RV college is available with the score you have got. Okay. Yes, Shashank. Shada Kanna, this is actually a session for exam 3. Okay, this is actually a session for exam 3. You will have physics, chemistry, biology classes, and even maths classes is coming up for exam 3. So I want you guys to make sure that you are attending the sessions very, very, very keenly. Fine. Okay. So yes, talking about electrochemical cell, as I told before, there are two types of electrochemical cell. One is galvanic and the other one is electrolytic. In galvanic cell, chemical energy is converted into electrical energy, but in electrolytic cell, electrical energy is converted into chemical energy. How will you remember this? Galvanic, G is somewhat similar to C in writing, which means D is C, galvanic chemical energy. In electrolytic, you have the term E, which means in electrolytic cell you convert electrical energy to chemical energy. You get the point? Yes. So very good, very good, very good, my dear. Rakesh, don't you worry, you are going to get seat in RV for sure. Just relax, chill and wait for the turn. Okay? Yes. So next we will talk about what exactly happens in a galvanic cell. So Dekanna, could you please tell me what exactly happens in a galvanic cell? Yes. Could you please tell me what exactly happens in a galvanic cell? Anyone, can you please tell me what happens? Lingam, when you will start KCET 2026 classes, soon, Dakana. We'll start maybe in the month of June. Yes. Shashank, Linga, Asha, Jay, quickly let me know what happens in a galvanic cell. You have to open up your mouth, Kana. You have to answer. You have to make sure that you are interactive. Even if your answers are wrong, it is completely fine. Come on, guys. Yes. See, always remember this term. Whenever a child cries, he will get the milk needed or he will get the food. Similarly, only when you start to answer the question, you are going to make things right. Okay, so if you know the answer or if you do not know the answer, even if you have doubt in your answer, just type it down. No one is going to see your face, right? So just type it down and the rest will be taken care by us. Fine. Okay. So, in a galvanic cell, you are going to convert a chemical energy into electrical energy. Can we have some example for a galvanic cell? Yes. Can we have some example for a galvanic cell? Say, for example, I'll give you this kind of a cell. So, do you know the name of this cell, Dakana? Anyone? Do you know the name of this cell? At anode, you have zinc. Cathode, you have copper. And yes, this is a galvanic cell. This is a type of galvanic cell. Could you please tell me? Yes. Yes, Dakana. Yes. Quick. Very good, Priya. I think only Priya is answering here. So yes, it is absolutely Daniell cell. Anyone else? Okay. So yes, what happens in a Daniell cell? In a Daniell cell, you have two cell, half cells. One is anodic half cell and the other one is cathodic half cell. So can you please tell me what exactly happens in an anodic, half cell and cathodic half cell? Very good, Rakana. So in an anodic half cell of a Daniell cell, oxidation occurs. Similarly, in a cathodic half cell of Daniell cell, reduction occurs. And my dear champions, in order to understand what exactly oxidation or where exactly oxidation occurs, where exactly reduction occurs, I will give you one small trick. And the trick is lone. Fine. So lone stands for L, left, O, oxidation, A, anode, and N, negative. Left, oxidation, anode, negative. So what does it mean, ma'am? I am unable to understand it. Just see or look into the Daniell cell, my dear. If you look into the Daniell cell, you can see that you have two separate beakers here. One is anodic beaker and the other one is cathodic beaker. In anode, you have your zinc dipped in zinc sulfate or zinc chloride solution, any solution of zinc. Similarly, in case of cathode, you have your copper dipped in copper electrode dipped in copper sulfate electrolyte. Ma'am, first of all, what do you mean by the term electrode and electrolyte? Dekana, in this device, na, you can see two elements at place. One is the beaker filled with liquid, and the other one is the metal piece or some kind of a strip, rectangular strip dipped in the piece. So here the liquid is called as an electrolyte. The liquid is called as an electrolyte, whereas the metal is called as an electrode. You get my point? The liquid is called as an electrolyte, whereas the metal is called as an electrode. So now what happens at anode and cathode? So now I'm going to start this. I'm going to make sure that they are starting to react. Fine, because in galvanic cell, chemical energy is converted into electrical energy. So I'm ensuring that they are about to or ready to react. So as soon as I put my zinc rod in zinc sulfate solution, my zinc in the zinc rod becomes zinc 2 plus and 2 electrons. Okay, you know that whenever you have an ion, it dissipates in the liquid. But what happens with 2 electrons, Rakana? You have 2 electrons now in zinc. What happens with 2 electrons? Quickly, Vedant, Muttu, can you please tell me? Priya, can you please tell me, Rakana? Yes. What happens to the 2 electrons? Will it move towards cathode or will it just mix with the liquid or will it just stay in the zinc rod? You have 3 options. 3 options. Quickly, let me know the answers, Dakana. Yes, I can see Priya answering. At the day, Priya is on fire today, my dear. Very good. Followed by Ajay Ram. Wonderful. Anamika. Super duper Dakana. Super. So what exactly happens here? So the electron which is, produced in the zinc or the anode moves towards the metallic wire and reaches the cathode. So now the electron has reached the cathode. So once it reaches cathode, what exactly happens? Yes, hi Scandium, Mr. Scandium, welcome on board, very good. So once it reaches cathode, what exactly happens, Rakana? Quick, bega answer Madi. Yes, big answer Madi. What exactly happens, Rakana? What exactly happens? Alright, once the electron reaches your cathode, your electrons are exactly going to attract the copper ions in the electrolyte. So just understand that here in cathode you have a lot of electrons. Okay, so on seeing these electrons from copper sulfate solution, your copper is going to leave your sulfato ions and going to reach out to the cathode rod. And once reaching out to the cathode rod, it will get the electrons and become copper metal. So here the copper ion, copper 2 plus ion reaches the cathode, gets 2 electrons and becomes copper metal. Now copper is a metal. So this metal is, exactly formed at the ends of cathode, which means the copper will form a layer throughout the cathode and ensure that the cathode becomes fat and bulky. Okay, so yes, this is how the reaction happens. So now you might have a doubt. Ma'am, if copper rod or cathode rod is becoming bulkier and bulkier, what about anode rod? Obviously, from anode, the zinc becomes zinc 2 plus and 2 electrons, which means the zinc 2 plus is going to completely dissolve in the electrolyte or the solution. And once again, the electron is also not staying, right? He is moving from anode to cathode, which means your anode is going to shrink. Without going to gym, he is going to shrink. Yes, so your anode is right away shrinking, becoming lean. Your cathode, on getting the electrons, on making sure that the copper 2 plus is converted into copper. This copper is deposited in the cathode. It becomes bulkier and bulkier. But just think of one thing, Dakana. If your anode becomes lean and cathode becomes bulkier, after a period of time, you cannot produce any electricity from this system. Right? Right? That is where the function of salt bridge arises. So, talking about salt bridge, I'll detailedly tell you on what exactly happens with the salt bridge, how a salt bridge is formed, and applications of salt bridge along with a video. Yes, you heard it right. Along with a video of how your entire reaction occurs. But as of now, just understand that yes, this is all what is going to happen with your cell or aka galvanic cell. Is that clear, Dakana? Is that clear? Is that clear? Array, is it so boring? Huh? Feeling sleepy? Or is it something like I am saying some kind of rhymes? Quick! Let me know, Dakana. Let me know. Are you feeling sleepy? Bega, answer Madi. Feeling sleepy. So, okay. We'll do one thing. Fine. If you guys answer to me with each and every question, then for sure I'm going to play a game with you guys. Will that be fine? Yes? Yes, can we do that? We have nearly 17, 19 members here. So if you answer each and every question of mine, in the end of the session, we will play a super duper game. Will that be fine? Yes, will that be fine? Shall we play a game? Are you guys ready? The game is going to be super enjoyable. So yes, I can see Mr. Scandium is on fire. I want every one of you here to answer me then and there. Okay? Paka? Fine. So let us talk about the overall reaction. Now you know that your in anode, your zinc becomes zinc 2 plus and 2 electrons. Obviously, loss of electron happens, which means it is oxidation. Similarly, in cathode, your copper 2 plus from the solution gets the electrons to become copper. If it gains electron, reduction happens. And what is the overall reaction happening here, Dakana? Your zinc indirectly get connected to copper 2 plus to form zinc 2 plus and copper. This is how the reaction occurs. Now you know. Yes, Muthu, Asha, everyone are ready to play a game. Super Dakana. Now you really know that your electron moves from anode to cathode. Electron is produced from zinc. Electron moves from anode to cathode. So quickly, can you please tell me how your current flows then? Right? Your electron flows from anode to cathode, which means how will your current flow? Current in a Daniell cell flows from, right? You have four options. Option A is cathode to anode, C2A. Option B is anode to cathode. Option C is through salt bridge to cathode. And option D is salt bridge, salt bridge to anode. Quickly, let me know the answers, Dakana. Hi, please, welcome on board. Yes. What happens with current flow? You know, electron flows from anode to cathode, which means what happens with the current flow? Quick, Dakana. Please, you're absolutely right, but let me know the answers. Let me know the correct answer. Hi, Sanjana. Welcome on board. Yes, you have four options. Option A, cathode to anode. Option B, anode to cathode. Option C, salt bridge to cathode. And option D, salt bridge to anode. So quickly let me know, Dakana. Sanjana? Yes. Like Madi, share Madi, subscribe Madi. So quick, Dakana. Yes, option A. Are you guys sure? Option A. I can see a lot of option A and you guys have nailed it. You guys have extremely nailed it, because yes, if the electron flows from anode to cathode, then the current flows in the opposite direction, which means the current flows from cathode to anode. So hooray, kudos, wonderful job. The current flows from cathode to anode. Very good, very good, very good, Rakana. Yes, I'll give you another question. Fine. Um, So we'll talk about cell representation and then I'll give you the question. Okay. So now in a Daniell cell, your zinc reacts with or indirectly, okay, because electron transfer vagera happens there. So your zinc reacts with copper 2 plus to form zinc 2 plus to form zinc 2 plus and copper. Fine. So now the question is, write the cell representation for this reaction. How will you write it? Hooray! You do not know how to write this, nah? So I'll let you know. Yeah, whenever they ask about cell representation, all you have to remember is AC. Not the AC which is there in your home. AC stands for anode, double bar, cathode. Anode, double bar, cathode. Here, double bond stands for salt bridge and anode will represent anodic reactant, anodic product, double bond, cathodic reactant, cathodic product. So quickly, based on the representation I have told you, right? And based on the consensus that yes, in anode oxidation occurs, in cathode reduction occurs, could you please tell me the cell representation of a Daniell cell? Just for this one. Could you please tell me the cell representation for this reaction? Yes, yes, yes. Quick, 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 Dakana. Please, please let me know the answers. Bega, bega, bega. Yes, 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 yes. What's the answer, Dakana? What's the answer? Scandium. Sanjana, just tell me the option, Dakana. I'll give you 4 options, okay? Just tell me, or I'll give you 2 options because it is super duper clear, na? So just tell me which one is the right answer. Fine. So your option A is going to be zinc, zinc 2 plus, copper 2 plus, copper. Option B is going to be copper 2 plus, copper, zinc, zinc 2 plus. So amongst these 2 options, which one could be the right answer? Yes, which one could be the right answer? Quick, quick, quick. Quickly, quickly let me know the answers, Dakana. Quickly let me know the answers. Okay, Scandium says option A. What about others? What about others? What about others? Muthu says option A. Very good, very good, very good. What happens, Anjana? Hi, bye. Yes, yes, yes. So the correct answer for this cell representation is absolutely option A. And why do we say option A, Dakana? Because, sorry for that, because I told you that whenever you write a cell representation, you have to take anode first and then cathode, right? So anode's reactant here is zinc, anode's product here is zinc 2 plus, then double bar, cathode's reactant is copper 2 plus, product is copper. That is why we say option A is the right answer, option A is the only answer, and option A is a very good answer. Pakka Dakana. You have done a wonderful job. Kudos, kudos, kudos. Pakka. Then we will move ahead with the next set of concepts, and that is your salt bridge. So, have you heard of the term salt bridge? Ma'am, of course we know about salt bridge, ma'am. The one which connects anode and cathode in a galvanic cell is called as salt bridge. Exactly. That is what a salt bridge is. But do you know how a salt bridge is made? Yes, do you know how a salt bridge is made? A salt bridge is made by, or it is made just like your jelly rakana. Yes, the sweet, tasty, yummy jelly which you make in your home or eat it from a restaurant or even, from small shops for maybe 2, 5, 10 rupees and all. Right? So, what happens here is they take a salt which has equal size and charge for their cation and anion. Here your anion and cation must have equal size and equal charge. Second thing, whenever you take that kind of a salt now, you have to ensure that you mix it either with agar-agar or gelatin. Ma'am, why should I mix it with agar-agar or gelatin? Can you please tell me what happens when you mix your agar-agar and gelatin in water? What happens? Yes? Yes, Sanjana, Scandia, Muttu, could you please tell me what happens when you mix your agar-agar or jelly with water and heat it? Yes, what happens? What happens? Do you remember? Do you remember what exactly happens? I will show you. Right. So what happens when you take your, agar-agar or jelly, mix it with water? What exactly happens, Rakana? You will form a jelly-like thing. Right? Yes. So what happens here is, at first you will take your agar-agar or your gelatin. You will put it in a bowl along with some water. You mix it well until or unless agar-agar and gelatin completely disappears in the water. And after that, you put some amount of the salt which is needed for a salt bridge, mix it, and then you must have seen this kind of a tube in your lab, right? Which is called as a U tube, right? U bend tube, right? So you take that tube, and in that tube you pour this liquid. And after pouring this liquid, you keep the setup untouched in say a stick or a stamper or whatsoever. Fine, you have to leave it aside to make sure that this salt jelly is ready. Fine. So, ma'am, why specifically agar-agar or gelatin? Because there is only one reason, Dakana. It forms a very good shape. It forms a very good paste with your salt without reacting with the salt. That is why we make use of it. Fine. So, once you make this salt bridge now, you will ensure that the salt bridge is placed in between your anode and cathode. Now, one quick question, Dakana. One quick question. Why do you use the salt bridge in between your anode and cathode? Can any one of you tell me why you should use a salt bridge in between anode and cathode? Sanjana, Scandium, Muttu, Linga, quickly, Dakana. Let me know. Why should you use one? Yes. No answers. Okay, just think of your, galvanic cell as a switch. Whenever the switch is closed and there is a complete flow of electron, your current is said to be produced, right? If the switch is open, if you do not have a salt bridge, if the switch is open, then obviously what happens? You cannot make sure that the current is flowing constantly, right? So this salt bridge acts as a complete switch system, which which will ensure that the entire system is closed. First point. Secondly, your salt bridge thereby ensures that electrical neutrality is met. So, ma'am, what do you mean by the term electrical neutrality? First of all, Dekana, you know that you have a lot of zinc 2 plus in the electrolyte of anode. You have a lot of SO4 2 minus in your cathodic electrolyte as well when the reaction occurs. So, whichever salt you have, the salt's anode goes to, the salt's anion goes to anode and cation goes to cathode, ensuring that this charge is being balanced. So, in order to balance 2 plus of zinc, 2K plus will go there. Similarly, in order to balance, 2Cl minus will go here. Similarly, in order to balance, SO4 2 minus 2K plus will go here, ensuring that the entire system is completely, thoroughly and clearly balanced. Fine. So, in order to maintain electrical neutrality, use the salt bridge. In order to ensure that you complete the inner circuit, you use a salt bridge. And thirdly, in order to minimize liquid junction potential, that is, in order to ensure that the liquids move up against the salt bridge and make a junction here. That junction is called as liquid junction, and since this junction of salt stops the electron flow, that is called as junction potential. In order to make sure that there is no liquid junction potential occurring, we will use our salt bridge. So this is how your entire salt bridge works, Dakana. If you have any doubts, please let me know. Please let me know. We will, smash it like anything and then move on with the next part. Yes. Hi, Pallavi. Hi, Suchitra. Hegide Kanna. Hegide. Yes, is that clear? Is that clear? Quick. Bega. Let me know so that we will move on to the next part. Yes, Pallavi, I'm doing great, Dakanna. Hope you're good as well. Yes. Okay, Pakka, super. So now we will go with the questions, and your very first question comes here. Right? So, big answer, Madi. Let me know the cell representation of this reaction. Big answer, Madi Kanna. Yes. Quick. Let me know the answers. Let me know the answers in the comment section. No one. Array, if you don't answer now, then there is going to be no game. Yes, if you don't answer, then there is going to be no game at the end. So quickly answer. Quick. Sanjana, Pakka. Very good. Others, please let me know the answers. See, I need 5 answers at least. Then we will, if I get 5 answers from 5 people, then we will ensure that we play a game at last. Okay? So, yes, Sanjana Ashok says option A. Dekana, just look into the reaction, Dakana. How did I say that the cell representation work? You will just write anode double bar cathode. Anode's reactant, anode's product, double bar, cathode's reactant, and cathode's product. Yes. So now look into the reaction, find which one is anode, write the reaction, which one is cathode, write the reaction, and let me know the entire cell representation. Yes. Quick. Muttu, option A. Dekanna, option A is not the right answer, Dekanna. A is not the right answer. Others, please let me know. Please let me know. Yes. Okay, which one acts as a cathode and which one acts as an anode here? How can I find this anode thing, ma'am? It's super confusing. I'll give you one trick. In the reactant end, whichever is or whichever acts as a metal, okay, that is your anode. And which one acts as an ion, that one is your cathode. So here, your copper is your anode and your Ag is your cathode. Now tell me the cell representation. It is anode reactant bar anode product. So copper bar copper 2 plus. Then cathode reactant cathode product. Ag plus and then Ag. So now let me know the right answer. The correct answer is going to be absolutely option C. You get the concept? Yes, you get the concept, Rakana. Okay. So next question. KCl is used in salt bridge because which one is the right answer? Big answer, Madi. I'll hide myself so that you can see the entire question, Rakana. Suchitra, Sanjana, Muttu, Vedant. Answer Madi, Rakana. Answer Madi. Yes, yes, yes. I'm looking out for some answers from you guys. Quick, 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 answer me, and this is going to be the last question. Okay, trust me, this is going to be the last question. So quickly, let me know the answers. Sanjana says option C. Okay. Priya says option D. What about others? Kavita says option B. Hi Kavita, welcome, welcome. So yes, Kanna, the correct answer for this question is absolutely option D. Yes, because KCl is used in the salt bridge, the only reason is your K plus and Cl minus ion has similar size and similar charge value, which means whenever your zinc 2 plus is at par in your anode or your sulfate ion is there in your cathode. These two ions, they will ensure that they have equal mobility, they move in or they run in equal speed just to make sure that they reach anode and cathode at the right time. Okay, so this is how you have to learn your electrochemical cell. Yes, we have a lot more sessions coming up. Even by 7 o'clock we have Catherine ma'am's session. So I want all of you to make sure that you attend the session and make sure that you are span and crystal clear with the concepts. Also, my dear, if you have to reach out to me anytime, you can reach out to me using Instagram or through Telegram. This is my ID, which is neat_Premila_chemistry. And if you want unofficial, jolly kind of videos, then you can reach out to Vedantu Karnataka channel, which is in our Instagram. So yes, my dear, we are here. So why fear? We will smash our exams, be it exam 3, be it upcoming KCET or COMEDK or NEET or what so and what not. So yes, my dear, with this we will wind up the session. Thank you so much for being in the session and we'll meet you in the upcoming days. Until then, this is Premila Ma'am signing off. Tada, bye-bye. Take care and have a great day. And one important thing, if you have any doubts, you can reach out to me in the comment section or through Instagram or via Telegram.